Hey everyone, Math 103. This is section 5.1, common factors. So factoring and multiplying are opposite operations. We can take these two factors, 6 and 2, and multiply them together to get 12. Or we can do the reverse operation, starting from 12, and break it up into its two factors, 6 and 2. So one thing we're going to do today is find the greatest common factor between two monomials. And the greatest common factor means the things they have in common. So to see what these two monomials have in common, I'm going to break them up, expand them into x squared, that's 2x's, y to the fifth, that's 5y's, x to the fourth, 4x's, y to the third, 3y's. And now we can go through and find matching pairs. So I got a matching pair of x's here, another pair of x's, and 3 pairs of y's. So those are the things that they have in common. So I'm just going to write those out. And then write it back in exponential form. So those are all the things that they have in common. So that is the greatest common factor of those two monomials. Your turn, number 1. I'd like you to expand both of those monomials just like I did here. Circle the common factors, and then write them out, and then write them out in exponential form. So there's expanded form. I'm going to circle some matches here. I'm going to write them all out, all the matches in expanded form, x, 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 y, and that equals, we have 3 x's, so that's x to the third, times y. So the greatest common factor of those two monomials is x to the third times y. Now this is a shortcut method for finding the GCF. And so what I'd like everybody to do now is take a look at the table and look for any patterns that you see. How do you get that greatest common factor from the two monomials without doing any expanding? So notice in the first row, we have x to the fifth, y to the eighth, and x to the fourth, y to the third. The greatest common factor is x to the fourth, y to the third. Well, 4 happens to be the smaller of the two exponents on the x base, and 3 is the smallest exponent on the y base. All right, let's see if that pattern continues as we go down. On the second one, the smaller exponent of the two x's is 2, and that's in the greatest common factor. The smallest exponent of the y's is 5, and that's in the greatest common factor, so it works there. Let's see if it works in the last one. We have x to the 12th and x to the third. 3 is the smaller, so x to the third is in the greatest common factor. We have y to the fourth and y to the 10th, and y to the fourth is in the greatest common factor. So that pattern continues all the way through. So to describe the pattern, for each base, select the smallest exponent. And that will work in finding the greatest common factor of any monomials. So let's try the shortcut then on your turn, number 2. So looking at the 2x base, exponentials, we've got 7 and 10, smaller exponent of 7, so we'll pick that one. And out of the two y bases, We have 9 and 6. The smaller of the two is 6. So the greatest common factor is x to the 7th, y to the 6th. All right, now we're going to find the GCF of numbers. And method 1 will be listing all the factors and then selecting the largest one, the greatest common factor. So all the factors of 12, these are all the numbers that divide evenly into 12. So 1, 2, 3, 4, 6, and 12. And for 16, you got 1, 2, 4, 1, 2, 4, 8, and 16. Now I'll look through this list. Let's pick the largest match. I'm starting from the biggest numbers, go down. First match I see is 4. So the greatest common factor of 12 and 16 is 4. Your turn, number 3. One way to find the factors is just to use your calculator. Take 12, start dividing by 1, 2, 3, and every time you get a whole number, then the number you divided by is a factor. So for 12, we got 1, 2, 3, 4, 6, and 12. And for 21, we got 1, 3, 7, and 21. Now the largest number that's in both lists is 3. So that makes the GCF of 12 and 21, 3. Part B. We do 18 and 24. Factors of 18 are 1, 2, 3, 6, 9, and 18. 24, we got 1, 2, 3, 4, 6, 8, 12, and 24. All right, largest number that's in both lists is 6. That makes the GCF of 18 and 24, 6. So that's the most straightforward method for finding the greatest common factor of a list of numbers. But it can get a little laborious if you have big numbers, writing out all those factors. So there's another method. And if you're going to go on to 104, it's probably best to learn this method. And it's actually helpful because it fits in with our smallest exponent technique for finding the greatest common factor of monomials. So prime factorization, there's a lot of different ways to do this. Some people like to use the tree method, some people a table. Got a little algorithm I use here. We want to find the prime factorization of 28. So I'm going to go ahead and use the table. So we'll divide if we can divide evenly by the first prime, which is 2, then we can do that. So 28 divided by 2 is 14. So we'll divide, and it doesn't matter which column you put them in. I'm just going to divide here, put the primes here, and then put the result here. Or you can switch them. Doesn't really matter. You could put the primes on the left. Divide here, divide by 2 to get 14. Okay, now look at this number. Now we're starting with this number. Can we divide this by 2? Well, it's even, so yes we can. So let's do that again. So another 2 here, and 7. Okay, now we're down to a prime number. So that means we're done. But I'm going to do one last thing. I'm going to divide 7 by 7 to get 1. And now here's our list of primes. So 28 is 2 times 2 times 7. And if you want to write it in exponent form, it's 2 squared times 7. Your turn, number 4. Find the prime factorization of 24. Now one note before you do that one, if you can't divide by 2, then try the next prime. Divide by 3. If you can't divide by 3, then try 5, and then just keep going. So 24 is even, so I'm going to divide by 2 to get 12. 12 is even, so I'll divide that by 2 to get 6. 6 is even, so I'll divide that by 2 to get 3. And 3 is prime, so I'll divide by 3 to get 1, and there's the list. So 24 is 2 times 2 times 2 times 3, which is 2 to the third times 3. B, I want to do 60. I'm going to divide 60 by 2 to get 30. I'm going to divide 30 by 2 to get 15. 15 is not even, so it's not divisible by 2. So I'm going to go to the next prime, 3. I'm going to divide 15 by 3 to get 5. And 5 is prime, so I'll divide by 5 to get 1. And then we're done. So 2 times 2 times 3 times 5. Two squared times 3 times 5. All right, so our second method for finding the GCF of two numbers involves the prime factorization. So what we're going to do is write out the prime factorization for each of the numbers, and then use the prime with the smallest exponent. So we want to find the GCF of 12 and 16. So 12 is a prime factorization of 2 times 2 times 3, or 2 squared times 3. And 16 is a prime factorization of 2 to the 4th power. All right, now, for each base, we're going to pick the smallest exponent. Well, 3 doesn't have a match down here, so this is like 3 to the 0 power, so we don't include that. So if it doesn't have a match, don't include it. Now for these, we do have a match between the base of 2, and we want the smaller of the two exponents. And the smaller of the two exponents is 2. So that's going to be in the prime factorization. In the greatest common factor. So the greatest common factor is 2 to the 2nd power, or 4. So that's the only match we had, so that's the only one we include. Smallest exponent is 2, so 4 it is. The greatest common factor of 12 and 16 is 4. All right, now let's do 20 and 30. So 20 has a prime factorization of 2 times 2 times 5, or 2 squared times 5. And 30 is a prime factorization of 2 times 3 times 5. Right, now we're going to find the matches. We got a matching 2 base here and a matching 5 base. 3 doesn't have a match, so it's out. Now for each one of these, we pick the smaller of the 2 exponents. We have 2 squared and 2 to the first power, so we want 2 to the first power. And then 5, they're both to the first power. So the greatest common factor is 2 times 5, which is 10. So no matter if we're doing variables or numbers, we want the smallest exponent. Your turn, number 5. Part A, find the GCF of 30 and 42. My first one, 30 is 2 times 3 times 5. 42 is 2 times 3 times 7. Our matches are 2 and 3. Everything's the first power, so the GCF is 2 times 3, or 6. Part B, 28 and 42. It's 28, 2 times 2 times 7. 42, 2 times 3 times 7. And we can write this as 2 squared times 7. All right, now we'll find the matches. Got a matching base of 2, matching base of 7. Small of the 2 exponent here is 1. These are both 1, so the greatest common factor is 2 times 7, which is 14. All right, now we're going to put these two things together, and we're going to find the greatest common factor of monomials with coefficients. So first example, (24) x to the 4th, y to the 7th, and 18 x to the 5th, y to the 6th. So we're going to start off by doing the numbers. 24 and 18. It's 24, 2 times 2 times 2 times 3, or 2 to the 3rd times 3. And 18 is 2 times 3 times 3, which is 2 times 3 squared. All right, matching bases. We have matching bases of 2 and 3. Smallest exponent in both cases is 1. So that makes the greatest common factor of 24 and 18. 2 times 3, which is 6. So that is going to be the greatest common factor of the monomial we get. All right, now we have to look at the variables. X to the 4th and x to the 5th. We got 2 matching x bases here. Small of the 2 exponents is 4. All right, so the coefficient is the coefficient. There's the GCF of the 2 coefficients, so that is 6. X to the 4th, and now we'll do y to the 7th versus y to the 6th. Smaller exponent is 6. So our GCF is 6, x to the 4th, y to the 6th. That brings us to your turn, number 6. Find the GCF of 4x to the 5th and 6x to the 3rd. So we'll do the numbers first. 4 is 2 squared, and 6 is 2 times 3. So our only matching base is 2. The smaller exponent is 1, so that makes the GCF of 4 and 6, 2. Now we'll look at the variable. We have x to the 5th, matching base, x to the 3rd, smaller exponent is 3. That makes the GCF 2, x to the 3rd power. B, we're going to find the GCF of 12, x to the 5th, y squared, and 20, y to the 8th. Let's do the numbers first. 12 is 2 squared times 3, and 20 equals 2 squared times 5. So now we've got a matching base of 2. 3 and the 5s have no matches, so we'll just look at the 2. Smallest exponent is 2, so there's your greatest common factor. 2 squared, or 4. And now we'll do the variables. We have x to the 5th, but we have no matching base over here. So x to the 5th, x bases are out. There'll be no x bases in the GCF. You have to have a match before you include it in the GCF. Now we'll look at the y's. Y squared and y to the 8th. Smaller exponent is 2, so y squared will be in the GCF. So the coefficient is 4, y squared. All right, next up we're going to factor monomials from polynomials. So let's look at the first example here. We got x squared y to the 5th plus x to the 4th y to the 3rd. Now I'm going to show you kind of a long-winded explanation here, and then we'll see a shorter way of doing it. But the explanation is important to see what we're actually doing. So first thing I'm going to do is expand everything. Now the greatest common factor we're going to find first, and then we're going to remove the GCF from both of these. Let's find the common factors first. There we got an x and x, there's a pair. We got an x and x, there's another pair. And we got 3 y's to pair up. All right, there's everything that's common to both terms. So that's going to be our GCF. So we got 2 x's and 3 y's. So what we do with the GCF is to remove it from both of these and bring it outside a pair of parentheses. So everything circled then is removed. And everything that's not circled is what's left over inside the parentheses. So we've got a couple of y's here, plus a couple of x's here. So that's the expanded form. Now we can put it back in exponential form. We have 2 x's, so that's x squared. 3 y's, it's y to the 3rd. And inside here we got 2 y's, so that's y squared, plus 2 x's, and that's x squared. And now this is the factored form of the original polynomial. Now we should check to make sure that it's right. So what's the opposite of factoring? It's multiplication. In this case, since we have this outside parentheses, we're going to distribute. So we distribute, we're going to use the properties of exponents. So we got x squared, nothing to combine that with, so that's going to stay x squared. Then we'll take y to the 3rd times y squared, Add the exponents to get y to the fifth. So that's where the first term comes from. All right, now I'll multiply this by the second term. X squared times x squared is x to the fourth. Y to the third, nothing to combine that with, so that stays y to the third. So when we distribute, we get what we started with. Your turn, number 7. I can do the same technique with x to the third, y to the fourth. Plus x to the fifth, y. Here's expanded form. Circle the matches. There's a matching x, another x, one more x. And we got a y and a y. So there's all the matches. There's our greatest common factor. So I'm going to pull this out in front. X, 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 y. Now let's see what we have left. We've got 3 y's here. And 2 x's remaining over here. All right, now let's convert it back to exponential form. We have 3 x's, so that's x to the third power times y. And inside the parentheses, we'll have y to the third plus x squared. Now most polynomials have coefficients. So now we're going to factor some with some coefficients. We'll put all these skills together. All right, now we're going to see a little bit more concise approach to this. You can always do the expanding method. That's totally fine with me. But this one, it's a little bit faster. So we'll start with the numbers, 24 and 18. So 2 to the third times 3 for 24. And 2 times 3 squared for 18. So greatest common factor then, we've got matching bases at 2. Smallest exponent is 1. Matching bases at 3. Smallest exponent is 1. So that gives us a GCF of 6. All right, now for the variables, x to the fourth and x to the fifth, smaller exponent is 4. Y to the seventh, y to the sixth, smaller exponent is 6. All right, there's our GCF. Now we need to figure out what goes inside the parentheses. So what we were doing there, with all the expanding and stuff like that, that can all be done now through division. So think of distribution. What operation are we doing with distribution? We're multiplying. Factoring is the opposite of distribution. So we're going to do the opposite operation, which would be division. So we're going to divide both of these by the GCF. So 24, x to the fourth, y to the seventh, divided by 6, x to the fourth, y to the sixth. Alright, 24 divided by 6 is 4. X to the 4th over x to the 4th, those cancel. Y to the 7th over y to the 6th, we do a single y. So 4y is a result of that one. Alright, now we'll do 18. X to the 5th and y to the 6th divided by 6 x to the 4th, y to the 6th. 18 divided by 6 is 3. X to the 5th divided by x to the 4th is x. And the x to the 6th powers cancel. So there's our two results, dividing both of these terms by the GCF. So our final answer then is 6 x to the 4th, y to the 6th. 4y goes inside, and keeping the same operation, addition, 3x. Now I'm going to do a quick check to make sure we've done it right. Distributing, 6 times 4 is 24. X to the 4th, nothing multiplied by here, so that stays x to the 4th. Y to the 6th times y is y to the 7th, so that one works. Now we'll do the second term. 6 times 3 is 18. X to the 4th times x is x to the 5th. And y to the 6th is y to the 6th. Your turn, number 8. All right, doing our prime factorizations. Got a matching base of 3, both to the first power, so the GCF of the coefficients is 3. Now we'll look at the variable parts. X squared and x to the 4th, smaller exponent is 2, so we get x squared down here. Y to the 5th and y squared, smaller exponent is 2. So there's the GCF. And now we'll divide both of these terms by the GCF. So 6 x squared y to the 5th over 3 x squared y squared. And that gives us 6 divided by 3 is 2. X squareds cancel. Y to the 5th divided by y squared. Subtract the exponents to get y to the 3rd power. Right, now we'll do the second term. 9 x to the 4th y squared over 3 x squared y squared. 9 divided by 3 is 3. X to the 4th divided by x squared. Subtract those exponents to get x squared. Y squareds cancel. So the answer here is GCF first. Then inside the parentheses, 2y to the 3rd plus 3x squared. All right, I'm going to distribute and check. 3 times 2 is 6. X squared is x squared. Y squared times y to the 3rd is y to the 5th. So that works. Now I'll do 3 times 3 is 9. X squared times x squared is x to the 4th. And y squared times 1 is y squared. All right, next example, we're going to do a polynomial with 3 terms. Got 10x to the 4th plus 20 x to the 5th minus 15 x to the 3rd. All right, numbers first. 10 is 2 times 5. 20 is 2 squared times 5. And 15 is 3 times 5. All right, now we need, since we have 3 numbers, we need the greatest common factor to be in all 3 of these. We've got matching bases of 2 here, but it's not in the 3rd one, so 2 is not included. The 3 is only in this one, so that is not included. What is in all of them is the 5. So that makes the GCF of the numbers 5. Right, now we'll do the variables of the x spaces. Smallest exponent is 3, so that makes the GCF 5x to the third power. All right, now we'll divide each of these by 5x to the third. So GCF goes out front. Now we'll take 10x to the fourth divided by 5x to the third. 10 divided by 5 is 2. X to the fourth divided by x to the third is x. All right, next term. Keep the sign, plus. 20 divided by 5 is 4. X to the fifth divided by x to the third is x squared. Subtract. 15 divided by 5 is 3. X to the third divided by x to the third is 1. So there is your factored form. Your turn, number 9. So out of 8, 10, and 4, we got 2 to the third, 2 times 5, and 2 squared. We have a matching base of 2. Pick the smallest exponent, which is 1, so we got a GCF of 2. All right, 3 terms here. Smallest exponent is 4, so that makes the GCF 2x to the fourth power. So that's going to go out front. Now we're going to divide each of these by 2x to the fourth. 8 divided by 2 is 4. X to the fourth divided by x to the fourth is 1. So 4 is the first term inside the parentheses. Subtraction, keep your signs. 10 divided by 2 is 5. X to the sixth divided by x to the fourth is x squared. Now we go 4 divided by 2 to get 2. X to the fifth divided by x to the fourth is x. 2x to the fourth times 4 minus 5x squared plus 2x. So that's it for today's lesson. This is going to be one of the most important skills we learned because we're going to be using it throughout this chapter.